Yes, we have a meteorologist. It's really, we've wanted to do this for several years, and Mark helped us find one. I apologize that we don't have a big green screen there so she can stand and point to the weather and everything, but this will have to do. And our meteorologist speaker is Kaitlyn McGrath, and right now she is the weather spokesperson for the CBS station in Washington, DC, WUSA Channel 9, which is one of the stations we watch. And we're just so grateful that she trekked up here, courtesy of her parents from Pittsburgh today. And she was educated, got her bachelor's degree at Florida, and she's been in the South. She was raised in Pittsburgh, so she's personally lived a lot of the weather that the United States has. Now, I got to be raised in Los Angeles, so we didn't have weather, but it's where she's going to describe to us the realities of being a weather person and doing climate change and having to explain. And Mark's point, I can just imagine how hard it is for her and all the other weather people to do this issue, which used to be just very straightforward. And now people watching them are they getting political? Are they, and get political with us. Go ahead.
Well, thank you, Bob, for that introduction. As you mentioned, my name is Kaitlyn McGrath, and I'm a meteorologist at WUSA 9 in Washington, D.C. And let me first say thank you for taking time out of your day to join me today for this really important conversation. The topic of climate change is one that I'm incredibly passionate about, and it really is at the forefront of my role as a meteorologist. So our conversation today is going to revolve around how warming global temperatures are changing weather patterns, disrupting the balance of the environment, and impacting us, humans, and so much of the ecosystem. Climatology really does play such an important role in my role as a meteorologist. Weather and climate go hand in hand. Weather is what you get. It's the current short-term atmospheric conditions. It's what I forecast on a day-to-day basis. But climate is such an important part of that. It's what you expect. It's the average atmospheric conditions over an extended period of time. And that knowledge of both is so important to be able to make the comparison of what we're forecasting and how that stacks up to what we expect. And as the climate is changing, so is my job as a meteorologist. And it's not just the changing climate, it's changing technology too. I'd be willing to guess that most of you have one of these, and you probably have at least one application on it that gives you the forecast to some extent. So we're finding that viewers aren't so interested in the temperature, the radar, the 7-day forecast. They can get that right in the palm of their hand. Instead, they're more interested in what's driving these changing weather conditions and climate data. It's becoming more and more readily available, and it's something that we as meteorologists should be using in our forecast because it is such an important part of our changing weather. In fact, a lot of the graphics and images that you'll see me use today are images that I do use in my forecast. So we're going to break this down kind of into 3 subtopics revolving around how we know our climate is changing. First, we're going to talk about climate records, the temperature and precipitation data that we have from hundreds of thousands of recording stations all across the world dating back to as early as 1880. And this shows us that evidence of warming air and sea temperatures is undeniable. And we will talk a little bit about how this is also human-driven climate change. Of course, climate does naturally change through natural processes. But what we've seen over the past several decades really is undeniable human-induced climate change. We'll touch on some of the physical changes, and I tried to pick examples that are relatable to us here in our region, in the Northeast. Specifically to me as a meteorologist, something that I deal with constantly is the severity and frequency of severe storms and resulting flooding events. I also deal quite often with rising sea levels as a result of melting glaciers. And we're also going to talk about worsening droughts because it is only a matter of time before we start seeing the headlines about the devastating wildfires through parts of the Southwest. And I also picked streamflow records as an example because during my time in Connecticut, I just moved to DC from Connecticut where I lived for 6 years. This was a climate indicator that I looked at quite frequently, and quite frankly, I just find it kind of cool. So I threw it in there as well. We'll also talk about some of the biological changes as a result of climate change, including our human health, shifting locations of species, and the timing of leafing plants. So again, I tried to tie all of these back into our region to make it a little bit more relatable. First, we're going to talk about climate records, our warming temperatures, and our precipitation that's increasing. What you're looking at here are the warming stripes. And I had a fear this would happen. My formatting is a little bit off, so I'll talk through what the text is being hidden. And as Bob mentioned, unfortunately, I don't have my green screen, so you'll have to forgive me for trying to gravitate towards the images to point towards them. But the warming stripes here are an illustration created by Professor Ed Hawkins out of the University of Reading in the United Kingdom. He created this image back in 2018 to illustrate the deviation from average temperature for every year since 1850 for the globe. And that's depicted in a colored stripe. Each colored stripe indicates an individual year. And the color corresponds to whether or not that year was below average or above average. And how dark or how light that color is corresponds to the deviation. And you can clearly see over the past several decades, centuries, the trend that we've seen. I want you to especially focus on the last century, how dark those shades of red have become, how much we have seen our globe warming as a result of human activity. Again, we talked about it at the beginning that, of course, there are natural processes that change the temperature of our climate. We had an ice age. But what we focus on is, more importantly, why we're seeing these warming temperatures. And a lot of it dates back to the early 1900s, shortly after the Industrial Revolution and the emissions of carbon dioxide and greenhouse gases that are trapping this heat in our atmosphere. These are the warming stripes for Washington, D.C. Not nearly as stark, right? Because we do see natural variations in our climate's temperature. But again, look back to 2010. Even as early as the early 1900s, and how much we have seen that shift from variations in some years that are a little below average, some years that are a little above average. We've clearly seen that shift of warmer and warmer temperatures. And again, that's specifically for the Washington, D.C. region. As our temperatures warm at the surface, we've seen significant changes in precipitation as well. As temperatures warm at the surface, we see evaporation increase. That moisture from the surface gets carried up into the atmosphere, and what goes up must go down. So as we've seen rising global temperatures, we've also seen significant shifts in precipitation. And I say shifts because for some, that has meant more precipitation. But look at the Southwest, where we've seen a significant decrease in precipitation. What this map shows us here is that since 1900, the average annual precipitation over the United States has increased by roughly 5%, or about a quarter inch per decade. But that's the average. Focus on areas in the Midwest, the Northeast, where we've seen a precipitation change of 10 to 15%, in some cases even higher than that. The trend that we've seen is areas that have always been wet are getting wetter, and areas that are dry are getting drier. We're seeing more of these extremes. This is a closer look specifically at the Northeast. This bar graph shows us the changes that we've seen since 1900. And the average does account for the severe drought we saw in the 1920s and 1930s and the 1960s. But what about the 1970s, 80s, 90s, 2000s, when we've seen these drastic increases in precipitation? Since 1900, precipitation has increased the most in the Northeast at an average of 8%, the Midwest with an average of 9%, and the Southern Great Plains with an average of 8%. And again, this all comes back to those rising temperatures. With rising temperatures, more evaporation, more moisture in the atmosphere. And between these precipitation and temperature changes, we're seeing a lot of these physical changes. Most relatable to me in my role as a meteorologist, again, the severity and the frequency in which we're seeing severe storms and flooding events. This graphic here depicts how heavy downpours are increasing. What's a heavy downpour? It's defined as a very heavy rain event that's defined by the heaviest 1% of all daily events from 1958 to 2012. So where we've seen the most heavy downpours increase is the Northeast, 71%. Increase since 1958 to 2012. Increasing more also in the Midwest at 37%, 27% in the Southeast, but not nearly as much in the Southwest, where we're seeing the opposite effect, right? We're seeing that evaporation take moisture away from the surface, and unfortunately, like us, they're not getting it back in the form of rain. From these increasing rainfall events, we're seeing increasing stormwater runoff. And I chose an example that hits very close to home here at Chautauqua Lake. Who here, by show of hands, has seen algae blooms on the lake? Anyone? Okay, quite a few of you. To no real surprise, they are becoming more and more common. For those not familiar with algae blooms, that's exactly what you're seeing there on your screen. This is an established bloom on Chautauqua Lake from 2019 that lasted around 8 weeks. And the duration of algae blooms can vary. It's very weather dependent. If it's really hot, those algae blooms will last for longer. If conditions are more favorable, they don't necessarily last that long. But algae blooms, incredibly harmful, not just us as humans, but the ecosystem in the lake. And these algae blooms are created by stormwater runoff. As we see heavier downpours, we see more stormwater runoff. And stormwater runoff is picking up sediment, fertilizers, pesticides, herbicides, gasoline, oil, litter, and a host of other environmental toxins, all of which are ending up in our water, the water that we like to enjoy. And it's creating these harmful algae blooms. You've probably heard of the algae blooms in the Gulf of Mexico. A much starker example, but something that they're dealing with to a much greater scale. And this is something that we deal with along the Chesapeake Bay as well. I've done a lot of research with the Chesapeake Bay Foundation on what these how these harmful algae blooms are impacting our local waterways. And one measure that they've taken are installing buffer strips, which to my understanding through some research is what Chautauqua County is planning on doing along the Chautauqua bodies of water as well. And what these buffer strips are is planted vegetation right along the banks of the water, not only along the lake, but all of the rivers and streams that feed into it that absorb that stormwater runoff. And a buffer strip really isn't just a strip. It generally is around 30 to 35 feet in width, but can be up to 100 feet wide. And those buffer strips really are essential to capturing that harmful stormwater runoff before it ends up in our bodies of water. This example, a little more meteorology focused, so bear with me here. We're talking about the increasing severity of storms. Severe weather, as defined by a thunderstorm that produces tornadoes, damaging wind, and/or hail, have accounted for nearly half of the billion-dollar weather disasters in the United States since 1980. Half of the billion-dollar weather disasters. And we're seeing more and more severe thunderstorms. The image that you're seeing on your screen here is showing the change in days with CAPE. Convective available potential energy. It's an ingredient that we look for on severe weather days, and it's increasing as warm, moist, rising air increases. We see more CAPE. It takes several elements in meteorology to create a big severe weather day, but CAPE is kind of a staple one. And this shows us the change in days with CAPE at or above 1,000 joules per kilogram since 1979. And 1,000 joules per kilogram is a lot, but most days nowadays, we're seeing days with upwards of 2,000 joules per kilogram of CAPE. Really unstable atmospheres. There's a lot of instability, a lot of moisture in the atmosphere, supportive of severe weather days. And as you can see through much of the eastern seaboard, really the eastern third of the United States, that's where we're seeing 20 to 40, and in some cases more days with that instability that creates severe thunderstorms. And if you're wondering why the eastern United States, there's really no change there. That's just always been the part of the country where warm, moist air from the Gulf of Mexico and the Atlantic Ocean is really readily available to help fuel these thunderstorms. As a meteorologist, we also deal a lot with sea level rise. That's shockingly been the case in a lot of what I've done in DC so far. I guess I didn't expect it to be as prevalent because we're not as close to the ocean as I was in Connecticut, but Connecticut is really where I got my familiarity with the importance and the impact of sea level rise as a result of climate change. We'll talk a little bit more about how it's relevant in DC coming up, but I do just first want to talk about what we're seeing in terms of sea level rise as a result of melting glaciers. So it all started shortly after the Industrial Revolution, when we started emitting a lot of carbon dioxide and harmful greenhouse gas emissions that are trapping that heat in the atmosphere. That started rapidly melting our glaciers. And as it stands right now, the Greenland and Antarctic ice sheets are the largest contributors to global sea level rise. The Greenland ice sheet in itself is disappearing 4 times faster today than it was in 2003. And it already contributes to 20% of current sea level rise. And here's the frightening part. If we don't cut emissions, the current rate of melting on the Greenland ice sheet is forecast to double by the end of the century. That's if we don't cut emissions. And I am rather hopeful that we're starting to make some progress. And I sure hope that we continue to make that progress. But if we don't, again, the current rate of melting on the Greenland ice sheet is forecast to double. And if in theory, all of the ice on Greenland melted, it would raise global sea levels by 20 feet. Just think about what 20 feet of sea level rise would do for all of this land that we love. That being said, that would happen about 1,000 years from now. So fingers crossed, we continue to make some great strides. But even if we do significantly curb emissions in the coming decades, more than a third of the world's remaining glaciers will melt before the year 2100. And this is just really one example of a very vicious cycle that we're seeing as a result of climate change. We have warming temperatures that's melting glaciers, that's raising our sea levels, that's causing more coastal erosion, that's leading to more impactful storm surge. All the while, we're seeing an increased frequency in these powerful storms that are causing impactful storm surge and in turn coastal erosion. Melting glaciers aren't just increasing our sea levels, they're also changing our global weather patterns. The Arctic is warming twice as fast as anywhere on Earth, and Arctic sea ice is declining by more than 10% every 10 years. And it's warming so much faster because of an effect called the ice albedo reflection. It's because ice is a very reflective surface, right? Ice, whether it's on water or on land, reflects the sun rays back into the atmosphere. It prevents warming. But as we continue to see warming in the Arctic and we see that ice melting, we're getting more and more dark spots on land and in water. So as the sun's rays shine down, they actually warm the land instead of reflecting them back as we have historically seen. And it's that melting ice that's disrupting normal patterns of ocean circulation. And the combination of warming air and ocean temperatures in the Arctic is creating changes in the jet stream that's allowed the polar vortex to extend far beyond the Arctic much more frequently over the past 4 decades. Show of hands again if you've heard of the polar vortex during the winter. Yeah. Most of the time it's accurately used, but sometimes the media will inaccurately use the polar vortex. It's not always the polar vortex every time you get cold air, but sometimes it is, and here's why. The image you see there on the left of your screen, that's a stable polar vortex. The image on the right shows a disrupted polar vortex. And the best way I could think to describe this was picture a top. Whenever a top is spinning in optimal conditions, it's on its axis, spinning rapidly, there's no disruption. But once it starts to wobble, once it starts to disrupt its normal pattern, you start to see it shifting more and more. And that's what's happening when you have a disrupted polar vortex. You start to see that cold air break apart and it pushes farther to the south. All the while, you have warm air advecting to the north, and that creates those significant dips in the jet stream, allowing those cold temperatures to make it all the way down to us. And that is when you truly have the polar vortex. So always important to fact check your local meteorologist if it is in fact a polar vortex or if it's just exceptionally cold. In addition to how much water we're seeing in the form of increased rainfall and rising sea levels, we want to talk about worsening drought because this is impacting a part of the country that may be far away from us, but it really does hit close to home for so many. The image you see there on your screen is the current US drought monitor. This was released last Thursday. It's released and updated every Thursday. I don't expect any significant changes to come tomorrow. And I want you to see how much of the country is experiencing those extreme and exceptional drought conditions. That's where you see a deeper shade of red and a darker maroon. Extreme drought is defined as major crop or pasture losses, extreme fire danger, widespread water shortages or restrictions. Exceptional drought is exceptional and widespread crop and pasture losses, exceptional fire risk, shortages of water in reservoirs and streams and wells causing water emergencies. We're already seeing this. It's more traditional that we see this towards the end of summer, but as we head into wildfire season, we're already dealing with these drought conditions across so much of the Southwest. And that's really where they are most at risk, right? We may be getting more rainfall here in the Northeast. They're seeing significantly less rainfall, significantly worse droughts, resulting in worse wildfires that can spread rapidly. Our desert land is expanding, reducing land for growing food. And areas of the country dealing with these severe droughts are also struggling with not having enough water on a regular basis, which when you think about, it's water. It's a resource that we sometimes can take for granted when so much of our country is not having a regular supply of it. And even if total precipitation remains the same through parts of the country, decreasing snowpack is having a significant impact on water availability, especially for our friends in the Southeast, where we're seeing these key regions that depend on snowpack, like the Sierra Nevada of California. The decreasing snowpack is impacting not only water management systems that rely on that spring snowmelt to replenish their reservoirs. That's where they get their water from year round, these slowly melting snows. Certain ecosystems also depend on snowmelt, like salmon. That's how they know to migrate. They get melting snowpack, that supplies the cold water that triggers their migration. And similar to how we talked about the Arctic melting, because snow acts as a reflective surface, whenever we don't have as much snowpack, that increases the surface temperature, further exacerbating drought conditions. Another vicious cycle that we see here. And here's my example of snowfall records that, again, is a little regional, because as you can see, all of the triangles there on the screen, that's depicting where we're seeing changes in the timing of annual high winter spring flow. They're all around mountainous regions. So you can understand why when I lived in Connecticut, this was really important, right? A lot of those gauges that are being recorded filter down into the Connecticut River. So that was a really important part of our springtime forecast. So again, this shows the changes in the timing of the annual high winter spring flow carried by rivers and streams from 1940 to 2018. Every large triangle that you see there in the mountains, that indicates where the springtime melting is happening more than 10 days earlier than average. The smaller the triangle, the less the deviation. And not only is spring water flow off occurring earlier, that should say earlier, not later, we're seeing less runoff. We're seeing less snowpack. We're seeing less runoff. We're seeing less of this water that ecosystems and water management companies have come to rely on. Correct, there are no blue triangles. No one is seeing the melting occurring later. Yeah, quite fascinating. You do see a couple little circles there, one up in New Hampshire, a couple in the West. That's where it's varying 2 days earlier or 2 days later, but no significantly later trends are being observed. So why does stream flow matter? And this extends beyond just those mountainous regions. This is stream flow across the entire country. High flows, of course, can cause erosion and damaging floods, whether that's from snowpack melt or just a significant rainfall event. Low flows can diminish water quality, harm fish, and reduce the amount of water available for people to use. The kind of disturbing image you see there on your screen are the fish remnants of the dry bed in the Rio Grande in Albuquerque, New Mexico. The Rio Grande has been struggling for decades with stream flow and lack of water in the area. And the timing, of course, of stream flow matters because it affects the ability for reservoir managers to store and meet the water needs of communities, and migrating fish depend on particular patterns of stream flow as part of their life cycles. They've come to know that water is where they expect it to be, right? So whenever they migrate, if it's not there, that's when we see loss of life in terms of ecosystems. Talking about some of the biological changes, most of which, of course, are driven by a lot of these physical changes. One of the most concerning ones, of course, is the impact to our human health. Our human health impacted by climate change in such a number of reasons. This is only a short sampling of them. Severe weather, injuries and fatalities related to severe weather, whether that's a tornado, whether that's a severe thunderstorm. We just had, unfortunately, some really bad, dangerous storms roll through DC just last week, or a hurricane. We're seeing increased injuries and fatalities as a result of severe weather. And of course, disruption of medical supplies. Whenever a devastating hurricane or any devastating system rolls through, it can create chaos in the entire community, and the folks that rely on medical supplies have unfortunately suffered as a result. Air pollution as a result of climate change. More and more folks struggling with asthma, respiratory infections, heart disease, lung cancer. And while all of us are at risk from these impacts of climate change, what breaks my heart the most is that those being the most impacted are our most vulnerable communities, those that don't have the resources that so many of us do. Increasing allergens, another really noticeable impact of climate change. If you suffer from seasonal allergies, you know what I mean. I'm taking my Claritin year round now because our growing seasons are just getting that much longer. We're seeing the first freeze occurring so much later and the last freeze occurring so much earlier that we're just seeing seasonal allergies stick around for that much longer. And of course, those suffering with asthma as a result of allergies know what I'm talking about. Water quality also being impacted by climate change. We're seeing more and more storm contamination, as we talked about, those harmful algae blooms, and that's creating more waterborne diseases and gastrointestinal diseases. Water and food supply, you've probably noticed, we've already talked a little bit about this in some of our examples so far, but we're seeing more and more crop failure, leading to food insecurity, malnutrition, diarrheal disease, and extreme heat. Talk about concerning as we head through the next several months. We're talking about cardiovascular diseases and the increasing heat-related illnesses and deaths. There's a lot of legislation out in Virginia right now trying to better educate folks on heat-related illnesses because it is becoming more and more prevalent in the DMV area. Thankfully, we have slightly cooler weather up here, but still a very serious concern moving forward, really for the entire country. Another example of human health is Lyme disease. This is the cases of Lyme disease in the United States since 1991. And just since 1991, over the past 30 years, it has doubled. And it's not just the cases of Lyme disease, it's where we're finding ticks that are carrying Lyme disease. The image on the left there shows ticks locations in 1996 compared to 2018. Not only are they spreading farther and farther north because they are finding that they can survive in those habitats, they're also surviving year round in many parts of the country. It used to be a seasonal concern, right? In the spring and summer, you need to look out for ticks. But with our warming winters, they're lasting that much longer. So Lyme disease, another big concern as it relates to human health. Also a shifting range of species here. I really enjoyed reading about this study by the National Audubon Society, where they studied 305 species of North American birds since the 1960s. That's what the image on the left there is depicting. It's showing us that of those 305 species studied, 186 or 61% have shifted their wintering grounds northward by more than 40 miles. Birds are heading to where it's more comfortable. 82 or 27% have shifted southward, and some others have not moved at all. And this, of course, depends on the climate habitats of these birds. You know, some birds can tolerate different climates. Others who rely on those cooler temperatures have been heading farther and farther north since the 1960s. Another example of shifting ranges of species, this shows the annual centers of biomass for three species: American lobster, red hake, and black sea bass from 1973 to 2019. And this is where I wish I had my green screen to point a little bit more, so bear with me. The lighter shades of dot you see is where these species were found back in the 1973. And worth noting that they chose to study these species because they represent a wide variety of habitats and they travel in large groups. They were relatively easy to study and get accurate data from. So the lighter dots indicate where the species were found in 1973. The darker shade, the darker that color has got, indicates where they are as of 2019. And the study found that the average center of biomass for these species shifted northward by about 20 miles between the years of 1982 and 2018. And what I also find fascinating is these species aren't just migrating northward, they're also going deeper into the ocean. As our warming waters continue to get warmer, they're seeking cooler water deeper in the water. So they've moved deeper, about 21 feet on average. An example that hits very close to home for me in regard to the timing of leafing plants are our DC cherry blossoms. The National Park Service has said that the Washington, DC area is warming at a rate of 3.3 degrees Fahrenheit per century. And that, of course, is impacting our historic cherry blossoms. Between 1931 and 1960, the average peak bloom date for those cherry blossoms was April 6th. Between the time frame of 1981 and 2010, that average peak bloom date moved up to April 1st. Just this past year, our peak bloom date was March 21st. The problem with that is once our cherry blossoms bloom, they're very vulnerable. And in the end of March, we are still seeing days and nights rather well below freezing. And once temperatures hit 27 degrees, those beautiful blossoms that bring so many visitors, so many tourists to the Washington, DC area shrivel up, and their lifespan is significantly decreasing as a result of which, when they bloom too early, they just can't take it. And I think it was about 5 years ago, it got so cold when they were still in their bud stage. They hadn't even bloomed yet that year. Got down to about 20 degrees one night and they were just ready to bloom. And it was just enough that that hard freeze killed all the blossoms and they never even bloomed that year. And this isn't, of course, just an impact in DC. It's an impact all across the world, the timing of leafing plants. The image here shows a study done by the National Park Service of 276 parks, including Alaska in the United States, where roughly 3/4 of which are experiencing springs earlier, and more than half of which are experiencing extreme early springs, meaning that the recent springs are among the earliest ever observed compared to the past 112 years. And all of the darker squares you see there, that's where that first leaf date at a rate per century change is between 10 to 25 days earlier. And there's a couple specific examples on there. Olympic National Park seeing their first leaf 23 days earlier than normal. Sleeping Bear Dunes in Michigan seeing their first leaf 12 days earlier than normal. And the Grand Canyon seeing their first leaf date 11 days earlier than usual. And what I want you to note here is how many of these squares are green. There are still some light gray ones, especially in the southeast, but think about it, their temperatures don't vary nearly as much as where we're seeing the significant changes of those first leaf dates. And I really like this quote by John Gross. He's a climate change ecologist with the National Park Service. He says, earlier springs, as indicated by leaf and flowering dates, is one of the most obvious and easily understood effects of climate change. And I like that because it's relatable not just to the leafing of plants, it's relatable to so many of the topics that we just talked about. You notice these changes over time, right? But sometimes we don't really think about what's driving them or why they're occurring. And I think the more we talk about climate change, the more we bring this climate data to light, the more people make that connection, and hopefully it starts to click a little bit more. Which leads me to my final point, that what can we as meteorologists do? First and foremost, we use our platform. To Mark's point, we're very thankful to have a wide-reaching audience. We're very thankful to have that role as the station scientist, that trusted source to relay scientific information. So I think the more that we spread accurate and timely climate data, the more folks will gain a better understanding. We also, as I alluded to earlier, are expanding our roles. We're not just sitting in the weather office, well, at least I'm not sitting in the weather office anymore, just crunching the numbers, coming up with the forecast. What's more impactful to me is actually getting out in the community and seeing firsthand how climate change is impacting our area, because the more I see it, the more I can help you guys see it. And bringing those stories to TV is so important to me, arguably more important than telling you the 7-day forecast every night at 5 o'clock. One of the most impactful stories I've done to date, and again, I've only been in Connecticut DC since November, so I'm really just getting started here, but it talks about the cherry blossoms in the tidal basin. In addition to a lot of reporting I did in the springtime about the blooming of our cherry blossoms, I did a follow-up story about the rising sea level and how it's impacting our cherry blossoms, because again, that was something I didn't expect moving to DC, but the Potomac River is a tidal river. It rises and recedes with the ocean tide. So as sea levels rising, so is the Potomac River. And every day, every single day without fail, the Potomac River flows over the banks of the tidal basin. The tidal basin is underwater for hours every single day. And that's killed a lot of our cherry blossoms, our historic cherry blossoms. The very cherry blossoms that were given to DC in the early 1900s are having to be removed because that brackish water is inundating the roots and killing the trees. And I think that was one of my favorite stories I've done so far, because a lot of folks in our community didn't know that. And it was one of those examples of an eye-opening firsthand look at what climate change is doing to our community. So as we use our platform and expand our role as meteorologists, my hope is that we can help close the gap here, and that by helping the public understand climate science will lead to greater acceptance and greater action. And these are some of my sources that I used for this presentation. Climate Central is one of my favorite sources for climate data nowadays. They've really expanded over the past several days. Climate Central is made up of meteorologists, climatologists, scientists from all over the world that work together to put together data and images that we can use as meteorologists. That's what a lot of those graphs that you saw were. They were data from Climate Central. So I so appreciate their efforts in helping us relay this information in a timely and accurate manner. And I would now like to open it up to any questions you may have. Thanks.
Hello.
Hello.
Sorry, sir. I know you're not here to talk about politics, but let's face it, this topic gets very political. If you even mention the word climate change, you get a bunch of angry emails. maybe even worse, you're part of a big corporation. Does your corporation tell you, no, you really shouldn't talk about this?
That really is a very interesting question, because when I first started working in television about 8 years ago, I wouldn't even dare murmur the words climate change. It was not a part of the conversation. And I think part of that may have been where I was living at the time. I was living in Charleston, South Carolina. But over the past really 5 years, I would say, our bosses say, do it, embrace it. If you can give out that accurate and timely information, they do encourage it, because it is such a highly politicized topic that I do feel an immense responsibility in my role as a scientist, as someone who spends hours a day researching these climate topics. I do find it an immense responsibility to accurately depict that information, but that's not the case everywhere. I mean, I have meteorologist colleagues in different parts of the country who, again, wouldn't murmur the words climate change because there's just such an adverse reaction in different parts of the country. So very thankful to live in such a smart market where it's very widely accepted.
Yeah. Excuse me. I've been teaching climate change when we used to call it what it really is, global warming, since 1983.
Wow, thank you.
Long before, at the college level, long before it became popular to talk about it. And so I've made a lot of observations. I'll going to mention a couple of things here that apply to your slides. One is that in addition to earlier springs, which we talked about, that causes the birds to have, migrating birds to have problems, because the food supplies mature before they get to them, and then they're gone by the time they get to them. So that's a serious problem for that, for the birds. Another one is why the storms are stronger now than they used to be. It's not just because there's more water in the air, which there is, but it's also because we have a change in the jet stream. The jet streams are more, they have been more gradual across the country, so the storms move right along. Now they're much more like this. So the storms keep hitting crosswinds and they slow the storms down. So that intensifies the rainfall of the storms. And that's one of the reasons why we see stronger storms, longer storms, and so on. But the most important thing that I have realized, and I don't think very many people realize this, is the cause of global warming. We've talked about carbon dioxide till we're blue in the face, and methane, we've entered that into the conversation. But the biggest absorber of energy in the atmosphere is water. And the dangerous thing that's happening is that the amount of water in the air increasing is causing more temperature to rise. So the water itself absorbs water. And the rumor in that idea is that as we raise the temperature of the air, we're raising the temperature of the water. And as we raise the temperature of the water evaporates faster. Is a global warming gas and is 40 times as prevalent in the atmosphere, we call it humidity, as carbon dioxide. And we can't stop the water from evaporating because 75% of the Earth's surface is covered by water. So we have to urgently stop the production of carbon dioxide much more quickly than the government is even saying. So that's.
Yeah, absolutely. I actually recently read a study done by NASA where if hypothetically we were to completely cut carbon emissions today, not a single carbon emission was emitted into the atmosphere, we would still continue to see this steady rapid warming for decades because the ocean is holding so much heat that would still continue to get released even if we cut our emissions.
I'd like to invite the people who are on Zoom to put your question into the chat and we'll get you in here. If you're able, we'd like you to use the microphone, but if you're not able, please raise your hand and we'll get the microphone to you.
Kaitlyn, you've gotten to see that one of the advantages of speaking at Chautauqua is that we have lots of experts who are here and can help comment. I'm an optimist, a lemonade out of lemons person, and I had hoped that at least global warming and climate change, while it creates lots of losers, was at least creating some winners. And like some of the weather up here has actually been better at times of the year. And I thought, well, it's going to be neat that tundra is going to melt in Russia and Canada, and there's going to be more land that can be used. But I think that we're finding tundra isn't very good for anything other than putting more methane in the air. What do you know? What do you know about winners from? Are there any winners?
Oh gosh, I mean, to your point, you know, summers in Chautauqua, I'm sure, are getting much warmer. Winters are getting much milder, which in some respects, yes, short term can be enjoyable, but I think when you think about what that means long term, it kind of takes away the short enjoyment of not seeing as much snow. That's a great question though, Bob, and thankfully I have your email, so I'll let you know if I'm able to think of any more substantial winners, but off the top of my head, I can't know.
Thank you for your talk. Are you familiar with the Mirror Reflection Project at Harvard?
No, I'm not.
It's imperative we've got to cool the planet. The quickest, easiest way to do that is put mirrors on 1.5% of the Earth's surface in desert areas. Also lime the world's oceans. Take limestone, grind it up, throw it in the world's oceans. This is a brilliant man that's running this project. We have the resources to do this. It'll buy us 30 years time. And as far as I'm concerned, it's the only hope we have at this point in time. So I urge everybody, meer.org. Again, that's meer.org. And we've got to do it fast. $50 billion to do this, but Elon Musk just spent 43 billion, buying Twitter. So now a question for you is, could you explain the Arctic Ocean to us better?
Yeah.
Are we going to have a blue ocean event this summer? And could you explain what that is?
I'm unfamiliar with a blue ocean event. Oh.
Yeah, traditionally we had 15 feet of ice on the Arctic Ocean during the summer months. Year after year it melts. Last year was just slush. So for and this year could be a complete blue ocean event, no slush. So what that means is for 6 months of the year, this huge ocean, the Arctic Ocean, instead of being a reflector, is an absorber of heat. So that's kind of what the Mirror Reflection Project is kind of reversing what's happening there. But serious scientists are very concerned that this will be the year that we have a blue ocean event there.
Interesting. Yeah, unfortunately, I'm nowhere near knowledgeable enough to speak on it accurately, but I look forward to researching it more after our discussion.
Okay, I've got another tough one for you.
Okay, great.
I think most of us understand the greenhouse effect. I don't think anybody understands what global dimming is. Can you explain global dimming? You
got me again. I don't know what global dimming is. I'm not familiar with the topic.
Dimming. It's also known as aerosol masking. It's the fine particles that come from our coal-fired power plants. The sky is actually dimmer, whether we realize it or not, when we look up now. If you were to stop all the coal-fired fine particles from going into the atmosphere tomorrow, you would have absolute catastrophe. Global dimming is masking global warming. In other words, it's making it not as bad. These fine particles are up there and they make global, right. So if you turned off all the coal fire plants tomorrow, global warming would get much worse. I mean, your slides would be much, much worse. So there's two major forces going on. One is global warming and the other is global dimming.
Interesting.
I want to mention one other scary one. And I follow people called abrupt climate change. And they're very scary people. They think they're very serious scientists, folks, that think we have 4 years left. These are very, very serious people.
Wow.
Yeah, I'll be off in 1 minute. For us as a species, that means you have about 7 major things, and if they start cascading, it's really, I have a handout if anybody's interested. See me at the back. Well, this is a small group. This is only 32 scientists, and this gentleman's right. The vast mainstream, Michael Mann, you know, are not nearly that serious, but there are serious people that think that. One thing I wanted to mention to you, because I thought you did a nice job explaining the polar vortex. So I live in Cleveland. We had a polar vortex about 3 years ago, and they're not fun during winter.
In Cleveland.
In Cleveland and Chicago, and Minnesota was even worse. What's horrifying about those is if they come down during late May and early June when the farmers are planting their crops. We live as a society year to year on the grain crops. If a polar vortex were to come down at planting season, stunt the crops, we would be in very, very serious trouble. Nobody talks about that at all. So anyway, I'll get off the, thank you so much.
Thank
you for talking.
Thank you. And on the topic of farmers, I was thinking about some of the winners that Bob mentioned. And I think some of the winners are those who are being tested by climate change and coming up with solutions that probably never would have even crossed their mind. I think of the example of, I actually just did a story with a local farmer on the eastern shore of Maryland, and farmers, as it relates to climate change, can get a little bit of a bad rap, right? Lots of methane pollution. This farmer, however, is acknowledging what's going on in the climate, how they're contributing to climate change, and trying to mitigate his personal carbon footprint by the idea of cover crops, which aren't anything new. Cover crops have been around for decades and decades. And the idea is that in the off season, he grows corn, soybeans, and some other seasonal crop. And in the off season, he plants these cover crops. He's created a concoction of kind of wildflowers and grasses that he puts in place of where his crops grow during the growing season. And that just has a number of benefits to his area. It absorbs stormwater runoff, something that farmers are really struggling with, especially in the past several decades. But it also helps preserve the quality of his crop. So when it does come time to plant all of his crops, soybeans, corn, etc. He doesn't remove the cover crops. He plants his crops within the cover crops. They inevitably kind of die off, and they help insulate the crops so that they do have a better survivability whenever they do start to grow in the summer months. So all that to say, I think some of the winners are those that are coming up with innovative solutions to climate change.
I'm asking this out of ignorance. What caused the Ice Age and the Little Ice Age?
That is a great question. And to my knowledge, again, not being a climatologist, the Ice Age was a result of the tilting on the Earth's axis and the way it rotated, causing those severe deep temperatures. But that's really all I can speak to accurately on the Ice Age.
Okay, we have a question from our online audience. You've talked about effects in the US. How much do we know about whether the US is representative of the worldwide changes or skewed towards one end of the bell curve?
That is a great question. And all I really did show from a global perspective is the global warming stripes, right? Because honestly, a lot of what I study is just in the United States, simply from the fact that there's only so many hours in the day and I have to focus my attention on what I can relate to viewers. So I honestly can't answer that very accurately, but great question. And I certainly will look into it after our conversation. Tippy toes.
Thanks. My name is Carrie. I was here last year when Megan Collins spoke. She's an environmental scientist and talked about how scientists don't communicate well with people. I spent 25 years teaching 5 different levels of chemistry in high school, and I always involved the environment. And I went back to graduate school and found out that me buying a Prius wasn't necessarily good for the environment because the battery is made from rare earth metals and they are not really required to recycle it. So I'm hurting the earth, though I'm not polluting as much as someone in their big truck. And what happens is there are millions of people that die every year because of pollution. And that's not getting across to the population. So I thought last year we discussed, and I stood up and said, we have to start talking to the kids to push their parents to recycle and do this stuff. How can we make people understand that there's a finite amount of time? I look at my 5 grandchildren and realize when they get to be adults, and maybe not grandparents yet, because everybody's having their babies really late, there's not going to be oil left. In 50 years, the oil's going to be gone. We can't just say, okay, we're going to go to all hybrid because that leaves other problems. So what can we do to make people see it's really important to start making changes in our life? If we all, billions of people, make small changes, it ends up being a bigger change. And I don't know how to get the scientists, because sometimes I talk, my husband looks at me like I'm talking Chinese or something. You know, he's not a scientist. And I think it's important to understand that everything we do has an effect on the rest of the people in the world. Do you have any words of advice?
I think just going back to my last slide is just that knowledge is power, whether that's on the broader scale, like we're talking about today, or like you said, little actionable items that people can take at home. Proper recycling, my gosh, just throw things out where they're supposed to go. That makes such a difference. Keeping food waste out of landfills by composting significantly reduces methane. I think we just have to have these conversations, and I think make it seem more significant, right? Because I think a lot of folks think like, oh, if I change out my light bulbs and make them LED, is that really going to make a difference? And it does. So I think all we can really do is talk about it. And like you said, start them young, because you don't think if a kid comes home and says, Mom, we should be doing this, they're not going to.
Right.
Mom, I would hope that you would.
I know, it's kind of scary to think what happens when we don't have oil.
Yeah, it
You know,
absolutely
look at
is.
what's happening in the world, and we're relying on countries that don't want to necessarily buy from.
Mhm.
So it's a little scary. I'm
Yeah.
like always like the sky is falling. So-
Well, I appreciate your question.
Hi, my name's Chris. Thank you for this wonderful discussion. I'm an amateur beekeeper, and for the last several years, I've noticed, you know, the bees go into a little ball in the winter to protect the queen, and because we've been having these big blasts of warm in January in Kansas City, it's sometimes hit 70 degrees for days, and the bees wake up, they say, yay, it's spring, they come out, there's nothing. And then the next week, like you said, with the cherry blossoms, there's this big shock. And I'm wondering, I heard you talk about ticks, and we're also seeing that. I live on a small farm and that's in the woods. We're definitely seeing that. For beneficial insects, you know, do you have any information on that, a source to look at?
I don't, but my best source of guidance would be to go to the EPA website.
Okay.
They have a lot of great climate indicators specific to migrating insects and animals.
One other quick comment. There's a woman in Richmond, Indiana. I'm currently at Earlham School of Religion doing a master's in peace and social transformation. And there's a scientist there named Pat Foreman, who's doing a lot of work with chickens and climate change. Because if we can pull all of our compostable yard waste, food waste, and use chickens to help compost it, this is a big contributor to methane. It saves municipalities money because they are not collecting all that. So there aren't dumping and tipping fees. There isn't that fossil fuel. So I think there are that's another thing that you might want to put in your, as a real positive possibility. And you get eggs for your leaves. So
Absolutely.
anyway, thank you so much.
I love that. Thank you so much.
I wanted to just make a brief comment about winters. The scientists that study climate change are big.
You can put the mic up a little higher.
The scientists that study climate change are are really big winners in this business. They've got much better financing in recent years than they ever had before. But the one that was the biggest winner is a man by the name of Dr. Manabe, who obtained the Nobel Prize in Physics this year, largely for his work on climate change. And he published a paper with co-workers in the 1960s and 1970, which demonstrated unambiguously that the Earth was bound to increase its temperature if the carbon dioxide content of back in 1970 were doubled. And so there were, in my view, a bunch of scientists that were losers too, because that work was so much ignored by science that we're way behind the times today that we would have been if Manabe's work had been more widely recognized and accepted in 1970.
Thank you.
No, you've had your share, Paul. So I want to thank Kaitlyn for letting us see what's behind the weather people. And I would have even more respect for what I see. I want to thank you all for being here. And as I said, the Permanent Church we make a contribution, and we've gotten more technology. We're having speakers. We are not just a nonprofit, we're a non-revenue organization. So we have a basket in the back, and you're welcome to make a donation so we can keep doing that. And several years ago, we had a speaker here, a fellow named Eugene Linden, who was the popular science correspondent for Time magazine. And he wrote a book called The Coming Instability. And it put these charts together, this kind of charts, and showed the period that most of us grew up in that was a golden age and relatively privileged and easy. That period was based on nice, stable weather. And if we can't get back to that, our grandchildren are going to be writing books about the instability that came. So let's do what we can. Thank you. We'll see you next week.